Hi, I'm Cornelius, and I'm here to demonstrate the functionality of our upcoming Kickstarter project, Somnolinc. This is the Somnolinc lookalike. A soft, machine-washable headband and soft textile electrodes. And as you can see, it's easy to put on and to take off. The textile electrode patch attaches to the control unit, while in the process sandwiching the headband in between. This design ensures only soft fabric touches the skin, no plastic clips or buckles. And here we have the Somnolinc workalike. This is the fully functional prototype we'll be using for today's demonstration. The key difference between this and the lookalike is that this prototype is not focused on aesthetics. We have a functional hardware and software prototype, but we still have to implement the light and sound sensors that will be included in our final Kickstarter product. And that's where we currently are. We can measure a full night, connect to the app, and analyze sleep. I'm now going to assemble and put on the workalike. This part is the amplifier and Bluetooth circuit. I'm going to attach it to the electrode patch, just like the lookalike. Let's move on to the software integration. This is the Somnolinc app. You can see on the calendar here we have dots representing sleep recordings from the last week where we've been testing the device stability. I'm now going to pair the headband to the phone via Bluetooth. And we're connected. Once paired, we enter live mode. We added this screen specifically for this demo so you can see the real-time data stream, as obviously we can't do a live sleep demo right now. And if you watch the graph, I'm going to blink. You can see the artifacts caused by my eye muscles in the signal in real time. The staging algorithm will detect my current state as wake, confirming that the sensors are active and transmitting. So what does blinking have to do with sleep? When you activate a muscle, it generates a small electrical current. And this current is what our electrodes register and is what you see here as a peak whenever I blink. But your brain also produces electrical currents. However, they are quite a bit smaller than the eye blink peaks. Despite their small size, our device is sensitive enough to record them as well. And by recording your brain's electrical activity during sleep, we can tell exactly which sleep stage you're in because each sleep stage has a unique electrical fingerprint. That's what EEG is, the clinical standard for measuring sleep. And that's what our device measures. Let's take a look at the data processing. This is the track tab showing last night's recording. Our nightly sleep quality score is calculated out of 40 points. It's not a black box, it's a transparent sum of 7 clinical metrics. Each of these metrics gets a point score, and if you add them all together, you simply get the overall score for the night. Here you can see the 7 metrics: total sleep time, sleep efficiency, and importantly, our architecture metrics, like slow wave sleep, sometimes referred to as deep sleep, and REM, which we can actually track because we use real EEG. For more information about these clinical metrics, check out somnolinc.com. Go to the track page and hit the Learn More button. Next is the Wake tab. This controls the hardware's smart alarm. So how does it work? The software uses the live sleep staging we saw earlier to find the optimal wake-up zone. Like a normal alarm, you give it a wake-up time. But instead of waking you up exactly at the time you set, our alarm aims to wake you only during light sleep, so you might be a little bit earlier awake than the time you set. The goal here is really to avoid sounding the alarm during deep sleep, because this is when you wake up feeling really groggy and not at all ready to start the day. But of course, it's an alarm in the end, so even if there's no light sleep window detectable, it will sound no later than the time you set. After all, even worse than waking up groggy is waking up and realizing you missed an important appointment. You can also use the alarm specifically for naps. For more information, check out somnolinc.com, go to the Wake page, and hit the Learn More button. Finally, the Improve tab. This uses the same AI engine we use to generate participant reports in our clinical studies. It provides context and helps participants to better understand their sleep health. Here you can see the chat history over multiple nights as the coach is establishing a baseline impression of my sleep. After each night, the coach first asks me for my subjective feeling about how I slept. It then provides the objective metrics and asks if they align with how I feel. This is very interesting, as our coach catches any significant discrepancy between the two and takes this into consideration. In my case, I slept worse than I thought. Once the baseline is established, that is, once 2 weeks of sleep have been measured to get a reliable impression of how well you rest, you can let the coach guide you to better sleep. Interacting with the coach is working well, but the functionality still needs to be ported from our proof of concept web app into the Somnolinc mobile app. We've made it available as a demo for you to try out yourself at demo.somnolinc.com. Let's take a look. Imagine I've just woken up and am now interacting with the coach to ask about my night. The coach first asks me about how I felt I slept. I'm going to select 8 out of 10. It then compares my subjective impression of my sleep to its objective sleep quality score to see if there's any discrepancy. In my case, there was none. It also presents a graph showing the time I spent in different sleep stages during the night. I can also opt for a detailed breakdown of the night. Here you can see all the clinical metrics, a text summary, and another graph showing my sleep positions. I'll get back to this later. I can dig deeper with questions like, where did I lose my points? Okay, so the coach says that I lost points from sleep onset latency. But if I don't know what that is, I could then ask, what is sleep onset latency? After which, it tells me that it's the time it takes me to fall asleep. The detailed report also provides information from the other sensors, like body position. So let's ask the coach about my sleeping positions. Show me my sleep positions. Here you can see that I spend most of my time in the supine position, which is on my back. As you can see, there's obviously much more here. Why not go explore it for yourself at demo.somnolinc.com? So that's the full ecosystem. The hardware captures the clinical grade data, and the software translates it into well-established clinical metrics, which in turn inform actionable coaching. Beside the sleep coach, we will also have a second AI engine we call the Explorer. It's less guided than the coach and more geared towards people who want to design their own experiments or test their own sleep modification, like biohackers. We'll have the demo for this ready soon. Go to somnolinc.com and join our newsletter to be notified when it's ready. In the meantime, for more information, go and check out the Explorer section on the Improve page. With your support, the funding from Kickstarter will go directly towards incorporating the additional sensors putting the finishing touches on the software experience and towards the professional manufacturing of the headband. Thank you for watching.